Hi guys, this is a presentation of a view of cloud computing. Defining cloud computing. Cloud computing refers both to the applications delivered as services over the internet and the hardware and system software that provide those services. The services themselves are called SaaS, or software as a service. The hardware and software is what we call a cloud. When a cloud is made available in a pay-as-you-go manner to a public, we call it a public cloud, and the service being sold is utility computing. A private cloud refers to internal data centers of a business or other organization not made available to the general public. There are three aspects that are new to cloud computing: the appearance of infinite computing resources available on demand, quickly enough to follow load surges, thereby eliminating the need for cloud computing users to plan far ahead for provisioning. The elimination of an upfront commitment by cloud users, allowing companies to start small and increase hardware resources only when there is an increase in their needs. And the ability to pay for use of computing resources on a short-term basis as needed and release them as needed. This means cloud computing could offer services below the cost of a medium-sized data center and yet still make a good profit. The classes of utility computing. Any application needs a model of computation, a model of storage, and a model of communication. On one end of the spectrum is Amazon's EC2. It looks like physical hardware, and users can control nearly the entire software stack. The other end of the spectrum would be application domain-specific platforms like Google App Engine, which is targeted exclusively at traditional web applications. Unlike EC2, App Engine has automatic scaling and high availability mechanisms, and it also has Megastore's data storage available. Microsoft's has a framework more flexible than App Engine's, but still constrains the user's choice of storage model and application structure. Cloud computing economics. There are cases where utility computing is favored over conventional hosting. When demand for a service varies for time, because cloud computing lets an organization pay by the hour for computing resources. When demand is unknown in advance. Using 1,000 EC2 machines, for example, for 1 hour costs the same as using one machine for 1,000 hours, so computations can be finished faster. Cloud computing is pay-as-you-go, so you pay for the hours you use, which is an example of usage-based pricing. Even if the pay-as-you-go pricing is more expensive, the benefits of elasticity and transference of risk make it worth it. Cloud computing's ability to add or remove resources at a fine grain, with a lead time of minutes rather than weeks, allows matching resources to workload much more closely. Because you have to plan for spikes in usage, you need enough resources to cover them, which means when the usage isn't spiking, you aren't using all of your available resources at all times. Estimates of average usage is around 5 to 20%. If the spike is overestimated, the waste can be worse. A spike can also be underestimated, which can turn away excess users. Users who are turned away may never come back. For example, slow response times may be a reason people turn from Friendster to MySpace and Facebook. The authors of the article have outlined the top 10 obstacles and opportunities for cloud computing. The table I'm using here is from the article, and it's basically a bite-sized look at the top 10 obstacles and opportunities. The first three affect adoption. Number one is business continuity and service availability. Existing services like Google Search have reputations for being highly available, and users expect new services to be similarly available. But a cloud provider could suffer outages for technical reasons like availability and non-technical reasons, including going out of business or being the target of regulatory action. An opportunity to overcome the obstacle could be to use multiple cloud computing servers. Number two is data lock-in. Storage APIs for cloud computing are not standardized. Customers can't easily move their data and program from one site to run on another, which could make switching providers difficult. A solution could be to standardize APIs so data wouldn't be lost when switching. Number 3. Data confidentiality and auditability. Many people are concerned about security because their data is out there somewhere. Users and providers are responsible for security. The primary security mechanism in today's clouds is virtualization. However, not all resources are virtualized, and not all virtualization environments are bug-free. Virtualization software has been known to contain bugs that allow virtualized code to break loose to some extent. These problems are similar to large non-cloud computing centers, though. The standard defense, user-level encryption, is also effective in the cloud. The next few affect growth. Data transfer bottlenecks. Data transfers can cost as much as $100 to $150 per terabyte, so transfer costs can quickly add up. One opportunity to overcome the high cost of internet transfers is to ship disk or whole computers. Physically shipping can be a lot faster than transferring over a network, too. Performance unpredictability. Different EC2 instances vary more in their input-output performance than in main memory performance. One opportunity is to improve architectures and operating systems to efficiently virtualize interrupts and input-output channels. Flash memory could also decrease input-output interference. Because it has no moving parts, it's faster to access. Scalable storage. It's not clear how to apply the properties of cloud computing to a persistent storage. There is an opportunity to create a storage system that would not only meet existing programmer expectations, but combine them with cloud advantages. Bugs in large-scale distributed systems. Removing bugs can be difficult because sometimes they can't be reproduced in smaller configurations. An opportunity may be relying on virtual machines. It may be possible for them to capture valuable information in ways that are implausible without them. Scaling quickly. Google App Engine automatically scales in response to load increases and decreases, and users are charged by the cycles used. AWS charges by the hour for the number of instances you occupy, even if your machine is idle. There is an opportunity to scale more quickly to save money. Scaling also conserves resources. Configuration hassles make it tempting to leave machines idle overnight so the startup time is 0 when developers return to work the next day. A fast and easy-to-use snapshot or restart tool might further encourage conservation of computing resources. And the last two, are about policy and business. The first one is reputation fake sharing. One customer's bad behavior can affect the reputations of others using the same cloud. An example would be blacklisting of IP addresses. Another legal issue is the question of transfer of legal liability. Cloud computing providers would want customers to be liable and not them. The second one is software licensing. Current software licenses commonly restrict the computers on which the software can run. Users pay for the software and then pay an annual maintenance fee. There is an opportunity for open source to remain popular, or simply for commercial software companies to change their licensing structure to better fit cloud computing. In conclusion, the prediction is that cloud computing will grow and scalability should be focused on. Applications need to scale both up and down rapidly, and the software needs a pay-for-use model. Infrastructure marketing should run on virtual machines. Billing and metering needs to be built in from the start. Hardware containers should be designed at scale with minimum purchase sizes. Cost of operation will match performance and cost of purchase in importance. Processors should work well with virtual machines, and flash memory should be added to the memory hierarchy. And LAN, switches, and WAN routers must improve in bandwidth and cost. My questions are, do the opportunities for cloud computing outweigh the obstacles? And how have you seen cloud computing used, or how can you imagine it being used in a library setting? Thank you.